Okay. Now we are going to discuss about the reaction mechanism. Write the notes very clearly. Reaction mechanism. Reaction mechanism. In reaction mechanism, we are going to discuss about the reaction intermediates. Reaction intermediates. Reaction intermediates. In reaction intermediates, write the points. The bond breaking is generally depends upon the bond breaking is the bond breaking is generally depends upon the nature of bond. Generally depends upon the nature of bond. Nature of bond. Nature of attacking reagent. That means nature of attacking reagent. Nature of attacking reagent and conditions of reaction. And conditions of reaction. And conditions of reaction. The bond in breaking is generally depends upon the nature of bond and nature of attacking reagent and conditions of the reaction. So this reaction intermediates is nothing but types of bond fusion or cleavage. Types of bond fusion. Or the types of bond cleavage. Means breaking. That we know already, homolytic, heterolytic. That one only we are going to discuss now. The first one is homolytic fission. In this, the types of bond fission, the first one is homolytic homolytic fission. Homolytic fission is nothing but if covalent bond breaks in such a way, if covalent bond breaks in such a way, in covalent bond breaks in such a way that each atom takes away from that each atom takes away one electron one electron of the shared pair. Of the shared pair. It is called homolytic or symmetrical. It is called homolytic. It is called homolytic or symmetrical fusion also. Or symmetrical fusion. Okay. Example. For example, this is A. It's bonded with B. Okay. The A bonded with B. If homolytic fusion takes place between two atoms, then what will happen? So these each electron takes each atom. This electron will comes to here, and this electron will goes to here. The resultant it can form. This is single electron, and this one also single electron. These both we can call as free radical also. Odd number of electrons. What are these? Free radicals. Free radicals. Okay, you know already the free radicals is nothing but which are present in odd number of electrons. Okay, the bond breaking in homolytic fusion here. We can break out the bond exactly. So the result of it, this electron will goes to on A and this electron will goes to on B. So here A and B both are free radicals. Okay. Okay, shall I remove this page? Then next I will continue. Now also 10 members are absent today. Okay, let them absent. So we'll see. In online classes, mostly around 10 to 15 days, or else this end of the month will go with organic chemistry only. అప్పుడు వాళ్ళకి అర్థమవుతుంది class importance. Okay, I am going to remove this page. Is it any objections? Just raise your hand. And next to factors favorable, no need the factors. Okay, write the some factors favorable the homolytic cleavage. Factors which favor the factors which favor the factors which favor the homolytic cleavage. Homolytic cleavage of bond. Homolytic cleavage of bond. Okay. In this, the first one, high temperature. The first factor is at high temperature, it may cause the homolytic cleavage of bond. High temperature. And the second one is ultraviolet radiation. In presence of ultraviolet radiation also, homolytic cleavage takes place. Ultraviolet radiation. And the third one, non-polar nature of bond. Non-polar nature of bond. Example like HCl, non-polar nature. And the fourth one, presence of free radical. presence of free radical. If free radical in the presence of free radical also, it may cause the homolytic cleavage. And the fifth condition, presence of peroxides. Presence of peroxides like your H2O2. Peroxides. And the sixth one, non-polar solvents. In the presence of non-polar solvents. These are the conditions to favor the formation of homolytic cleavage. Okay, and next heading, the second one, heterolytic fission. We completed homolytic. In homolytic, we will get the free radicals. Next to heterolytic. Heterolytic fission. Heterolytic fission. When a covalent bond joining two atoms, when a covalent bond joining two atoms, NING here, joining two atoms, A and B. A and B breaks in such a way, A and B breaks in such a way that both the electrons of that both the electrons of bond pair are being shifted towards bond pair are being shifted towards more electronegative atom, being shifted towards more electronegative atom, more electronegative atom. The mode of cleavage is called heterolytic fission. Heterolytic fission. This one also easy only, nothing there in this one, which is having high electronegativity atom that can pull the electrons from other element. The result of it will get negative charge, and one more will get positive charge. That is called heterolytic fission. For example, just assume A, it's bonded with B, Nana. Just B is a more electronegative than A, then what will happen if B is more electronegativity than A? This B can pull the electrons from A towards itself. The result of it, what will happen? This A will get positive charge and B will get negative charge. In this case, the B is more electronegative atom. The B is more electronegative atom. Okay. If A is more electronegative atom, what will happen? If A is more electronegative than B, so the result of it, what will happen? The electrons are shifted towards the A. So the resultant compound is A will get negative and B will get positive. In this case, the A is more electronegative atom. The A is more electronegative atom. Okay, that means simply in homolytic fission, almost the electronegativity atoms are of the elements are equal. So just A, it's bonded with B. If it is homolytic fission, what will happen? A get one electron and B get also one electron in bonded pair. So these we are calling free radicals. What are those? Free radicals in homolytic fission. In heterolytic fission, if B is more electronegativity than A, then what will happen? The B can gain the electrons from A. The A will get positive and B will get negative. Okay. So this A we are calling as electrophile. This A we can call this all electrophile. Why? Because this is plus charge. Electrophile. And B is, this is electrophile, and B we can call as a nucleophile. Nucleophile. If the less electrons compared than normal, that will be electrophile. If the more electrons compared than normal, that is the nucleophile. I think everyone understood these free radical, the formation of free radical and formation of electrophile and nucleophile. If the homolytic fission takes place between the two atoms, there will be the possible it can form free radicals. If heterolytic fission takes place the both two atoms, it can form electrophile and nucleophile. Okay, shall I remove this page? Is it clear about the homolytic and heterolytic fission? Anyone, if you get any doubts, just raise your hands. This is easy one only. Okay, I am going to remove this page. Right. And next one, keep the heading organic reagents. Organic reagents. Organic reagents can be classified into two types. Organic reagents. Organic reagents can be classified into two types. What are those? Simple. One is electrophile, other one is nucleophile. That's it. Organic reagents can be classified into two types. That is, one is electrophiles. Electrophiles. And the second one is nucleophiles. The second one is nucleophiles. In this, the first one, keep the heading electrophiles. Electrophiles. Electrophiles and nucleophiles nana. Electrophiles and positive, nucleophiles and negative. Okay. Electrophiles, electron deficient species. Electrophiles is nothing but electron deficient species. Electron deficient species. Or electron acceptor. Electron deficient species or electron acceptor. How you are saying this is electron acceptor? Because of it's having one unpaired it will have empty electrons, so it required electrons, that's why it can electron acceptor also. Electron acceptor. is electrophile. Electrophile. These can be classified into two categories. These electrophile can be classified into two categories. These can be classified into two categories. Two categories. The first one, charged electrophiles, that is positive. In this, the first one is charged electrophiles. The charged electrophiles. Actually, electrophiles classified into two types. One is charged electrophiles, that is nothing but positive charge. Positive charged. Okay, charged electrophiles are positive charged. Here, positively charged ions, positively charged ions, positively charged ions, in which central atom has, in which central atom has incomplete octet, are charged electrophiles. Incomplete octet are called charged electrophiles. Charged electrophiles. Yes or no? Positively charged ions which are central atom has incomplete octet. That means less number of electrons compared than normal. That is called charged electrophiles. Example here, H plus and X plus and R plus. R is nothing but alkyl group. And NO2, nitro group also it is electrophile only. And NO, nitrous group also electrophile. And SO3H, sulfonic acid also electrophile, etc. These are charged electrophiles. And next one, neutral electrophiles. Next one, keep the headings, the B, neutral electrophiles. Neutral electrophiles. Here, neutral electrophiles means neutral covalent compounds. Here, neutral covalent compounds in which central atom has incomplete octet. Incomplete octet is neutral electrophile. Is neutral electrophile. neutral covalent compound lo incomplete octet undali. Example BeCl2. We know that one already, that BeCl2 we learned in chemical bonding in last year also. Beryllium chloride, this beryllium, it will have 4 electrons. Actually, to get the stability, the atom should have 2 or 8 electrons in their outermost shell after bond formation also. So that only octet rule. But here the beryllium, it contains less number of electrons compared than normal. For example, here beryllium, its valence electrons are 2 only. When it's bonded with the chlorine atoms, the chlorine atom valence electrons are 7. I'm not going to write the total valence electrons. Actually, here 1, 2, 3, 4, 5, 6, 7. Here also 2, 3, 4, 5, 6, 7. So, okay. Now, with respect to this beryllium and chlorine, with respect to chlorine, we'll get the octet electronic configuration. Here also, with respect to chlorine, it is getting octet electronic configuration. But when it comes to with respect to beryllium, it's getting only 4 electrons. Only 4 electrons. That means this is incomplete octet rule. But this is stable according to hybridization theory. But now this is according to Lewis dots. This is incomplete octet rule. So such a type of incomplete octet rule elements also, compounds also called electrophiles. That is neutral electrophiles. Is it clear? I will give more examples here. That is example number 1. And next examples I am going to write here. BH3. Next example number 2, BH3. This one also incomplete. And ZnCl2, zinc chloride. And AlX3. And next FeX3. X is halogen summer. And next CH3 free radical. And CH2 methylene free radical, etc. Okay, I am going to remove this page. Shall I? Okay, I am removing this one. Okay. Okay, after removing, I will explain BeCl2, how it will get the incomplete octet rule. Actually, according to Lewis dot symbols, the beryllium valency 1s2, 2s2. That means the valence electrons are beryllium. You know, already in chemical bonding, only valency electrons are participating in the bond formation. The beryllium is having valence 2 valence electrons. Okay, now. So that means beryllium, it forms 2, it is ready to bond with the 2 electrons. And next, chlorine. Here, this is beryllium, it's having 2 valency electrons. And next with the chlorine. Okay, chlorine, it's having 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Here also one more chlorine it's having, it will have 7. So that is 1 and 2, 3, 4, 5, 6, 7. This is the valence electrons are chlorine, and beryllium valence electrons are 2. Now the bond formed between these 2 electrons, between this one and between this one. Now with respect to chlorine, this bond, now this electron belongs to chlorine as well as beryllium. This electron belongs to chlorine as well as beryllium. So now with respect to chlorine, how many electrons we are getting? With respect to chlorine, we will get 8 electrons. Okay. With respect to chlorine, we will get 8 electrons. And with respect to beryllium, we will get sorry, with respect to other this chlorine also we are getting 8 electrons only. Okay, but here with respect to beryllium, we are getting only 4 electrons. So according to Lewis dot symbols, the element should get the 2 electrons after bond formation or 8 electrons. If it get the 2 electrons, that is following duplet rule. Duplet is nothing but helium electronic configuration, and if it get 8 electrons, that will follow the octet rule. So in this both cases, that all are stable compounds, but here beryllium is getting 4 electrons. That means incomplete octet rule. According to Lewis dot symbol, this is a unstable compound. He thought this is unstable compound. It is not possible to form the beryllium chloride, but beryllium chloride is a possible compound, and it is existing compound only. That was explained by the hybridization concept. That this is the one of the drawback of Lewis dots. So this is that was explained by the hybridization concept. That means the finally we can conclude that the beryllium, it's having 4 electrons after bond formation with chlorines. That means it is having incomplete octet electrons. That incomplete octet electrons also we can call as neutral electrophiles. Okay, na? This is incomplete octet electrons. So that's why these are called neutral electrophiles. Okay, is it clear, everyone? Neutral electrophiles. Did you understand how the beryllium is got 4 electrons? Okay, Natali, అర్థమైందా? Shall I remove this page? Okay. Okay, fine. One more time I am revising. Just who came now, just to take it this all screenshot. Reaction mechanism we are discussing now. Reaction mechanism is nothing but reaction mechanism, and in this reaction intermediates, the type of bond fusion or cleavage. Simple. The bond breaking are generally depends upon the nature of the bond, nature of the bond and nature of the attacking reagent. Actually, the bond breaking is depends upon two. One is the nature of the bond, and next one is the nature of the attacking reagent. Okay. The first one is homolytic fission. That means if covalent bond breaks in such a way, each atom takes away 1 electron. Each atom takes away 1 electron of the shared pair is called homolytic or symmetrical fission. Example here, A and B both will have the same electronegativities. That means they both will get the electrons. The bond breaking will take place in the between. That is called homolytic. And these electrons are will goes to B, and this electron will move to A. Okay. So the result of it, A will get the positive, and B, sorry, A is this is free radical, odd electrons, and B also free radical. This is odd electron. Okay, na? And next one is that the factors favor the homolytic cleavage. Then which factors will favor the homolytic cleavage is high temperature. At high temperature also homolytic fission takes place. Ultraviolet radiation. That means UV rays. And non-polar nature of the bond, and presence of free radical, and presence of peroxides. Peroxides example we can take H2O2, hydrogen peroxide, and presence of non-polar solvents. And heterolytic fission is opposite. When a covalent bond joining two atoms A and B breaks in such a way that both the electrons of the bond pair are being shifted towards the more electronegative atom. Okay, now here we are assuming in this case, the case number 1 and case number 2. In this, the first case, what is that? In the first case, the B is more electronegative. That's why the B can pull the electrons from A towards itself. So the result of it, the A will get positive and B will get negative. Okay, na? The session will end within 1 minute, amma. And in this case, the A is more electronegative, the A will get negative and B will get positive. Okay. And next paragraph is electrophiles and nucleophiles. Electrophiles is nothing but electron deficiency. What is the meaning of electrophiles? Electron deficient species. Electron acceptor or electron acceptor is called electrophiles. It can classify into two types: charged electrophile, nuclear electrophile. Charged means positive amma. Positive charged ions with central atom as incomplete octet are called charged electrophiles. Neutral covalent bonds in which central atom has incomplete octet is neutral electrophiles. These are the examples. Okay. Remaining will continue tomorrow, same time 5:30 to 6:10. I am going to end the class. Is it any doubts?